We're discussing what will happen in the plastic region in a compression test for the engineering curve. To understand this behavior, you can see that after the yield point, for a certain stage, you observe same effect as tensile test. But after this, you have like an inflection point, and then it will be much more difficult. You need to have a high rate of increase of the force to continue deformation. To explain this, we should look at when we have compression test, what will happen. When you have a compression test, you will tend to have an increase in the area of the specimen. And in particular, at these zones where you have attachment between the specimen and your plates, which will cause the compression, here you will have friction forces between the two that will try to oppose expansion of this area. So this will lead, if you want, to the formation. With more you compress, this will lead to the formation of this shape of your specimen. So because you have high resistance at the ends, high resistance forces to expansion of area, more you compress, these friction forces will increase, and this will require larger forces F to be applied to continue compression. This is why at a certain stage you will observe that this will become dominant when you compress a lot. So this behavior will be very clear for high compression strain. Okay, and then these forces, these friction forces developed at this level will be very high, which will require, to overcome them, and continue compressing, I need to increase a lot the force. And you know that in the stress strain curve, which is the engineering stress strain curve, the variation of the graph represents the actual variation of the force, because you are dividing by A0 and the original area. So because at a certain stage, when you compress a lot, the friction forces developed here will increase in a very fast rate. This will lead to a much higher, much faster increase of F in order to continue the compression test. Okay, while for the first, when you go in the first region, when you go from elastic to plastic, we know that in the plastic region, it's easier to deform. This is why for a certain zone, you will see that F is increasing, but the rate is decreasing. Okay, because in plastic region, it's easier to deform than an elastic one, until the effect of this friction become dominant, and this friction is increasing in a very fast way, which requires a faster rate of force increase to continue the compression process, the compression test. So this explains the observation of this behavior for compression. Now, what is nice is that when you go to true curve, the true curve behavior is very, very similar to the tensile test. Why? Because in the true curve, you will actually divide F by the actual area. And it's true that F is increasing to continue the test, but at the same time, the area is reduced. So as you continue your compression test, the area is reduced. So when you take the effect of both, the increase of F and decrease of A, you will observe that the curve of true stress strain in compression is very similar to the one in tension, but you don't observe necking. Necking effect is only characteristic of tension. In compression, you don't have this. You will still have an increase in the area, okay? And at a certain stage, why we say we have rupture, and the rupture will be in, if you want, as a deformation. It's not that you are separating the specimen into two parts, but you will reach a certain high deformation state, so that you consider that my specimen is not anymore, if you want, the form of it will be deformed. You will have a certain, we call it barreling effect. So at this stage, you will say that I can consider that I will stop my compression. And you have a certain failure, but different than necking. Okay, so I will repeat these ideas in brief next time. And you will see that for the curve of engineering, it's a true curve. It will be very similar to tensile test. So if you want to plot it here, it will be like this and then like this, but without necking. At a certain stage, you will have end of the compression test, but no necking part. Okay, so we will see together after that what is interesting about this, that we can determine the values of the behavior of compression. We can deduce it from the behavior of tension for ductile materials. So no need to perform, for certain materials, no need to perform both compression and tension tests. You can deduce one properties of compression from properties of tension. Okay, thank you, and we continue next time.